All right, so let's take a look at this. It says the very first thing that you need to do is you need to know if it's arithmetic or geometric. All right, so we're going to talk about what does arithmetic and geometric mean. Before I begin that, just tying into what we've been doing before, sequences are different from functions. So even though they're going to look really similar in terms of the equations, you need to know that they're different from functions because they deal with n's, and n is equal to 1. We don't start at where x is equal to 0 like we do in functions. Because remember, your start in functions is always go find where x equals to 0, the y-intercept, right? But in sequences, it's going to be different because you start where n is equal to 1. Now, a sequence looks like this. It's just numbers separated by commas. There's no x and y. It's just numbers separated by commas. All right, so let's take a look at the first one. Arithmetic. All right, that's what it puts me in the mind of, which means what? Like math, numbers, right? So an arithmetic sequence is similar to a linear function. Now, when I say similar, I mean it's not exactly the same, it's just similar. So it's similar to a linear function, and it's a sequence of terms that have, now linear, you add from one thing to get to the other. So it has a common, what we call a common difference, and it's referred to as D. All right, so once again, you are adding and subtracting, and really what is that you're adding? It's the second term. I guess we can just say y2 minus y1. That's how you find it. Second term minus the first term. All right, so let's look at two things. Within arithmetic, you're going to have two separate formulas. One's going to be explicit and one's going to be recursive. They are going to give those to you. So you see arithmetic, recursive, and explicit. So I'm just going to copy them down as I see it on the formula sheet. So for explicit, I have a sub n equals a1 plus n minus 1 times d. For recursive, I have a sub n equals a sub n minus 1 plus d. Okay, so these are the two formulas that are given. And you're like, what in the world is this? Okay, cool. Don't lose track. It's okay. It's not that big a deal. It's not hard, okay? I'm just going to tell you what each of these things mean. So this a sub n just means the nth term. And what that means is let's say this term right here, it means the one that goes on like all the way this way forever. So like kind of like infinity. What is that term all the way at the end? All right, this means your first term. So you see how it says A1? Your first one, your first term. So what will be my first term here? -1. What about here? 48. Okay, so it's just your first term. Then n is strictly the number of term. So, for example, this is the first, the second, the third, the fourth. So if I asked you what is n here, it's 4. This is the fourth one. So n is 4. And then d is what we just talked about, the common difference. And how do you find the common difference? You do the second one minus the first one, if it's arithmetic. Okay? And you can see that it's the same thing here. The only difference is this is a of n, so it's the nth term. This is a n sub 1, so we don't have that. So let me go ahead and define that. This is, if this is the 10th term, for example, so I said this is a10, this will be 10 minus 1, which would be the 9th term. So this is the term before this one. All right, so term before that one. And I'll show you, that will make sense as we kind of work on it. Okay? So that's arithmetic. Now we're going to look at geometric. Okay, so arithmetic is adding and subtracting. Geometric is similar to what we just worked on, which is exponential functions. So it's similar to exponentials. This is a listening check. Color in exponentials. Okay, and what that is a sequence of terms that have a. Now this one had a common difference, but in exponential functions we're multiplying from one to the other one, so that's going to be called a common ratio. And that common ratio is referred to R for ratio. And just like we did in exponentials to find, how it's changing each time, we did y2 divided by y1. All right? y2 divided by y1. And that gives you what number you are multiplying by. Just like in arithmetic, you're going to have two types of formulas, explicit and recursive. Okay, so if you look at the formula sheet, you're going to go find geometric, and you're going to copy down recursive and explicit. And then we're going to go over how you use these formulas. So a to the n equals a1 times r raised to the n minus 1. The recursive one is a sub n equals r times a sub n minus 1. Okay, now a sub n means the same thing as this one, it's the nth term. A sub 1 is the same thing as the first term. The difference here is r is now your common ratio. And then n minus 1, remember n is a number of terms, so number of term minus 1. So the only new one here is r, which is your common ratio. And that's found by taking y2 divided by y1. Second one divided by the first. Okay, looking at this formula, you know a sub n already is the nth term. R is the common ratio. And then you have a sub n minus 1. So remember, it's just like this, but subtract 1. So it's just like here. It's the term before that. This is the term right before this. So if this is 10, this is 9. If this is 15, this is 14. It's the one right before it. Okay, so a couple of things that we need to know. So one is a sequence arithmetic or geometric, and we're going to know that in terms of if it's arithmetic, you're going to add or subtract to get to the next number. If it's geometric, you're going to multiply by something to get to the next number. The second thing you need to know is which formula do you use? Do you use explicit, which is straight to the point, like it's exactly what it is, or recursive to, which is like the way I remember this is you write in cursive. If you're writing in cursive, if I wrote Ainley in cursive, because I'm writing in cursive, I need the last letter to do, that sucks. I need the last letter to write the next letter. So that's how I remember recursive. Recursive is you need the last term to write the next one. So that's why I've kind of highlighted cursive for you to remember you need the last one to do the next one. All right, so now we're ready to look at some examples. Now we know what's what. All right, so let's take a look at the first one. So here I have a series of numbers. My first question is it arithmetic or geometric? And how do I know? 8, and it says the second minus the first. So the second minus the first is negative 7. So my common difference from here to here is minus 7. And if I do negative 8 minus 7 and I get negative 64, then it is arithmetic. So I have right now, so negative 1. If I subtract 7, see how I get negative 8? If I subtract 7 again, because I'm saying the common difference is negative 7, I should get this. I do not. I get negative 15. So is it arithmetic? No. So this is not true. Okay, so it's not arithmetic. So now I'm going to check if it's geometric. Geometric says if you take the second term, you divide by the first term, that'll give you the common ratio, the number you keep multiplying by. So let's do that. So let's go the second one, negative 8 divided by the first one, negative 1, is 8. So I'm saying to get from here to here, I'm going to multiply by 8. And I'm just going to check if that's true. So I go negative 1 times 8 gives me negative 8, times 8 gives me negative 64, and then I'm going to say times 8 again. So times 8 is negative 512. So check all numbers, because sometimes I've seen questions where it works for the first two, but not for the last ones. Okay, so check all the numbers. So that's definitely geometric. So it's geometric with r equals to 8. What does that mean? The common ratio, the number you're going to keep multiplying by is 8.
Next one, arithmetic or geometric? So 67 minus 48 is 19. 67 to 85, so 85 minus 67 is 18. And is 19 and 18 the same thing? They are not. So there's not a common difference, so it can't be arithmetic. Okay, look at geometric. Okay, 67 over 48 gives me some crazy decimal. Is that the same as 85 over 67. When I look at it in a calculator, it isn't. So it can't be geometric, so it's actually neither.
Now, they're going to give it to you in word prompts. I don't care what they do. It's just the same thing over and over and again. Find your numbers. Okay, so he's picking flowers in the garden. He picks 32. So you write down 32. You don't trip. And then 26. And then 21. And then 16. Okay, boom, boom, boom. Now you have numbers just like you had here. So it doesn't matter that they give you words.
So, arithmetic or geometric? 32 to 26, so 26 minus 32, that gives me -6. 26 to 21 is -5, and 21 to -16 is also subtracting 5. Okay, so these are not common, so it can't be arithmetic. What can I multiply by? 26 over 32, is that the same as 21 over 26? It sure isn't, so it can't be geometric, so it's neither. Alright, Carrie is planting flowers in her garden. She plants 1 flower in the first row, 4 flowers in the second, 16 in the third, and 64 in the fourth. What kind of sequence? So 1 plus 3 is 4, 4 plus 12, that can't be arithmetic, no way. So geometric, 1 times what is 4? 4 over 1, 4. 4 times what is 16? 4. 16 times what is 64? 4. So it's geometric because I'm multiplying by 4 every time. Writing sequences. It's saying what's the first 3 terms of the sequence. So 1, 2, 3. Alright, so I'm in. And then my rule is n minus 3. And the question wants me to start when n equals 1. So that means 1 minus 3, which is -2, is my first term. For n is 2, 2 minus 3 is -1, which is my second term. And the third term, 3 minus 3 is 0, which is my third term. Okay, do the same thing with the next one. It wants to know the first 4 terms, though. N, and then I have 4 times 4 to the nth power. So when n is 1, 4 times 4 to the first is going to give me 16.
This is a listening check. Put a box around the number 16.
My second term, 4 times 4 to the second, which gives me 64. My third term is 4 times 4 to the third, which gives me 256. And my fourth term, I can plug it in, or I can just do 256 times 4, which will give me 1024. So 256, 1024. So those are my first 4 terms of that sequence. So, finding a specific term. Find the 6th term of a sequence described below where n is the position of term. So 6th term means n equals 6. So 6 minus 7 is -1. That's my answer. Find the 4th term. So that means n equals 4. So I have -64 times -2 to the 4 minus 1. Plug that just straight into a calculator. We have 512.
To be continued in the next video.